In this lesson, we'll discuss learning target number 1. I can convert units using a conversion factor and report the answers to calculations with the correct number of significant digits. There's a standard system of units called the SI system. It was derived for use among scientists around the world, so that we're all communicating in the same language. So it doesn't matter if you're a scientist from Canada, China, Japan, or Russia. We all measure and record quantities using the same units. Length is measured in the unit, the meter, mass in a gram, volume in a liter, temperature in a unit called kelvins. We'll get to kelvins in unit 5. And the amount of a substance is described in the unit called the mole. We'll discuss moles in this unit. If the measurement you're taking is very large or very small, we use SI units in combination with metric multiples. Now, some of these multiples you've probably seen before. The base unit goes in here. So if we're talking about length, it would be the meter. If you have 1/100th of a meter, it's known as a centimeter, and a small c is placed out in front, or a 1/1000th a meter. The ones above you probably know in reference to computers. We measure memory in the base unit bytes. Well, if you have 1,000 bytes, it's called a kilobyte. 1,000,000 bytes, that's called a megabyte, and so on. This chart you do not have to memorize, but it's handy here to show you the different metric multiples that can be used. I find the easiest column to use is the one showing the multiple as a power. Then I can ask myself how many of these smaller units are in a larger unit by seeing how many powers of 10 difference there are between them. For example, how many centimeters are there in a meter? Well, meters have an exponent of 0, and centi have an exponent of -2. That means that centimeters are smaller because they're on the list, and there's 2 powers of 10 difference. So a 1 and 2 zeros, or 100 centimeters in a meter. Now I'm sure everyone has converted from one unit into another before by picking up the decimal place in the number and moving it left or right, depending on what you're converting into. In chemistry, we want you to use a different technique known as a conversion factor. This becomes handy because using a conversion factor, you'll be able to convert anything into anything else. You can convert centimeters into meters, you can convert kilometers into millimeters, you can also convert from one chemical to another using a conversion factor. You can't do that by picking up a decimal and moving it to the left or to the right. So this is how you set up a conversion factor. You take the number you're given, and then you multiply it by the fraction what you want, and divide it by what you have. Here's an example. If I have 25 meters, how many centimeters are there in that? Now, you could pick up the decimal and move it, and then you know there's 100 centimeters in a meter. What we're going to do is we're going to times by a conversion factor, though. I know it might seem like more work now, but trust me, you'll get used to it, and it'll become essential for you to use the conversion factors later on in this unit. I'm going to times by the unit that I want. I want centimeters, so I put it on top of my fraction. And I divide by the unit I already have, meters. And then I ask myself, how many centimeters are there in a meter? Well, there's 100. So I put 100 up top and I put 1 on the bottom. Mathematically, why conversion factors work out is because the units cancel. Here I have meters divided by meters, and the only unit that I'll have left is centimeters, which is what I want my answer in. Then I will do the math. 25 times 100 divided by 1. That's 2500. You'll get the same answer as picking up the decimal place and moving it 2 to the right. But I want you to try using conversion factors. It becomes necessary when we're converting one chemical into another. Here's another example. Here I'm asked to convert 35,600 millimeters into kilometers. Using a conversion factor, I would times by the unit that I want, kilometers, and divide by the unit I already have, millimeters. And then I'd ask myself, how many millimeters are there in a kilometer? That's a tough question. That's not something I do every day. I could look at this chart and see how many powers of 10 difference there are between millimeters and kilometers. It goes from 10 to the 3 to 10 to the minus 3. That's a power difference of 6. Or I could do this in stages. There's 1,000 millimeters in a meter, and there's 1,000 meters in a kilometer. That means I need to have 6 zeros in my conversion factor. My units cancel, and I'll be left in kilometers. So now I do the math. I do 35,600 times 1 divided by 1,000,000. That gives me 0.0356 kilometers. I want you to take some time and try some of these questions. I don't want you to pick up the decimal place and move it left and right. I want you to convert these units using conversion factors. There's lots of space over here for you to do your work and put your answer in here. Pause the video until you've answered all of the questions. Here are the answers to the conversion questions. The most common conversions we'll do in this course is changing milliliters into liters, changing kilograms into grams, or milligrams into grams. Each of these conversions has 1,000 smaller units in the larger unit. In order to handle very large and small numbers, scientists use a technique based on exponential notation. To express a number, we use a coefficient multiplied by base 10 raised to a power, or an exponent. To make it scientific notation, the coefficient must have only one number in front of the decimal place. The exponent tells you how many places the decimal has been moved, and in which direction. If the exponent is positive, you have a large number and the decimal place was picked up and moved to the left. If you have a very small number, you have a negative exponent because the decimal was picked up and moved to the right. Here are two examples. The number 2700 in scientific notation is expressed as 2.7 times 10 to the 3. This is because the decimal is here at the end of the number. If I pick it up and move it so that there's only one digit in front of the decimal, I have to move it to the left 1, 2, 3 spaces. That gives me a positive 3 exponent. My second example is 0.00045. It's expressed as 4.5 times 10 to the minus 4. In order to get one digit in front of the decimal, I have to pick up my decimal place and move it 1, 2, 3, 4 spaces to the right, giving me a negative 4 exponent. Different brands of calculators have different ways to enter scientific notation. Look at your calculator and see if you have an EE button or an EXP button. This is what you want to use when you're entering a scientific number. Try typing in the number 2.7 times 10 to the 3. In order to do that in your calculator, you type in 2.7, then hit your EE or EXP button, and then hit 3. You never have to type in the times 10. The EXP button takes care of this for you. Now if you hit equal sign, depending on your calculator, you might see different things. You might see your calculator expanded out to 2700. You might see it entered as 2.7 with a little times 10 that pops up and an exponent 3, or you might see it as a 2.7, a space, and then a 03. That space indicates it's a scientific number and you need to write down a base 10 every time you see that. I want you to try out some questions using scientific numbers. Question 1, change these values into scientific numbers. Question 2, do the reverse, take these scientific numbers and expand them out. And then question 3, do some math with your calculator. Answer these scientific numbers in, and then express your answer in scientific notation. Now if you use your EE or your EXP button, if you're doing math with scientific numbers, you don't have to put these numbers into brackets. Pause the video here until you've answered all 3 questions. Here are the answers.